What if the most powerful telescope ever created by humanity has just shown us something we were never meant to see? What if this wasn't simply a new scientific discovery, but a revelation that threatens to upend the very foundations of modern cosmology? For decades, science has operated on a fairly stable model of the universe. It began with the Big Bang nearly 13.8 billion years ago, followed by a long process of cooling, expansion, and gradual structure formation. Galaxies, stars, and planets emerged in predictable stages, each governed by physical laws we believed were universal and unchanging. But now, the James Webb Space Telescope, a machine designed specifically to peer into the earliest light of the cosmos, has returned data so unexpected, so contradictory to our models, that even some of the world's top physicists are expressing a rare mix of wonder and fear. One Nobel Prize-winning physicist, after analyzing the findings, broke years of professional silence with a statement that sent shockwaves across the scientific community. This is not our universe. This isn't hyperbole, it's not clickbait, it's the result of precise data collected by one of the most advanced scientific instruments ever launched. The James Webb Space Telescope was positioned at the second Lagrange point, nearly 1 million miles from Earth, away from our planet's interference, to give it a perfectly stable, unobstructed view of deep space. Its sensors are tuned to the faintest wavelengths of infrared light, the oldest and most redshifted signals in the cosmos. The telescope's mission was straightforward: to look back in time and capture images of the first galaxies, the earliest stars, and the primordial structures that emerged just after the Big Bang. But what it found may have changed everything. It began not with a blinding flash or a dramatic anomaly, but with a quiet, unassuming patch of sky. A region long considered cosmically uneventful, virtually empty, and devoid of anything noteworthy. To previous instruments, it had registered as little more than background noise, a sliver of deep space that, if anything, might offer subtle traces of ancient light or diffuse radiation from the early universe. There was no expectation of anything significant, and yet as the James Webb Space Telescope trained its unprecedented infrared sensitivity on this pocket of darkness, something unexpected emerged. In the raw data, amidst a field of near invisibility, Webb captured what looked like a faint, yellowish smudge. To the untrained eye, it could have been dismissed as a dust artifact, a processing error, or a digital echo from the telescope's optics. But it wasn't. It was real. And once astronomers began to analyze its structure and redshift, the implications became immediately staggering. That tiny, blurred splotch of light turned out to be a galaxy. And not just any galaxy, but the most distant and ancient galaxy ever observed. According to its redshift value, it had existed just 290 million years after the universe was believed to have begun. In cosmic terms, this is the equivalent of an infant walking before it's even born. Galaxies take time to form. Stars need to ignite, dust needs to cool and collapse. Massive structures require gravitational scaffolding to assemble. But here, in the observational data, was a massive, luminous, and clearly defined galaxy from an era that should have still been governed by heat, chaos, and disorganization. According to every model of physics and astrophysics that underpins our understanding of the cosmos, this galaxy should not exist. There simply should not have been enough time for gravity to shape gas into stars, for those stars to cluster into spirals or spheres, and for a galaxy to burn this brightly so soon after the Big Bang. But the shock didn't end there. This ancient galaxy was not an isolated fluke. As Webb's Deep Field survey continued and its sensors expanded their coverage, it revealed more. Not just a few, but dozens of similar galaxies, each of them blazing from the same impossibly early epoch. They weren't dim, misshapen clumps of matter barely in formation. They were massive, structured, and sophisticated, some even resembling modern galaxies in shape and brightness. These were not primitive building blocks, but fully operational cosmic cities, burning with energy and star production at a scale that contradicted every timeline in our cosmological textbooks. What made these findings even more astonishing was their apparent abundance. These galaxies were not scattered, rare anomalies. They were frequent, populating regions of space we had previously considered embryonic and undeveloped. The early universe, as we understood it, was supposed to be dominated by a seething plasma of hydrogen and helium, gradually cooling and condensing over hundreds of millions of years. Matter was supposed to be evenly distributed and largely inactive, punctuated only occasionally by small fluctuations in density that would later feed the first galaxies. Instead, Webb was showing us a cosmos teeming with activity, brightness, and structure in an era that was supposed to be quiet, dark, and mostly lifeless. These observations sent shockwaves through the astrophysical community. The foundational models that describe the universe's growth, including the widely accepted lambda cold dark matter (LCDM) model, began to look increasingly inadequate. The timeline of cosmic evolution was no longer a smooth arc of slow progression. It now seemed to include abrupt leaps, unexpected efficiency, and a degree of order that suggested we may have misinterpreted what early even means. Researchers scrambled to find alternative explanations. Maybe we had miscalculated distances or misread redshift. Maybe these galaxies weren't as old as they appeared, but the data remained consistent, confirmed by multiple instruments, vetted by independent teams. The light was coming from the dawn of time, and it was speaking clearly. The anomalies didn't stop with timing or brightness. Webb began to uncover galaxies that weren't just large or distant, they were impossibly efficient. In modern galaxies, only a fraction of available gas, typically around 10%, is converted into stars during a galaxy's lifetime. The rest remains in clouds of gas and dust, fueling star formation slowly over billions of years. But these early galaxies, some appeared to have converted virtually 100% of their gas into stars, as if the process had skipped the usual stages of slow condensation and gone straight to the final act. There was no dust left, no diffuse gas, just dense, glowing fields of starlight, packed into volumes that defied our models. It was as though the universe had fast-forwarded through its own rule. Such a level of star formation efficiency isn't just unusual, it's physically implausible. It would require unknown mechanisms, forces, or conditions not accounted for by current physics. These galaxies had to somehow bypass the turbulence and inefficiencies that plague modern star formation. They had to overcome radiation pressure, magnetic fields, and feedback loops from exploding stars, all of which normally slow down or limit stellar birth. The fact that multiple galaxies were found doing this at the same early cosmic moment suggests it wasn't a one-off event, but part of a broader cosmic process we have yet to understand. As a result, scientists are now facing one of the most challenging moments in modern cosmology. The data isn't wrong, the instruments aren't malfunctioning, the redshift measurements are holding. What's crumbling is our interpretation of the cosmic past. Something doesn't add up, and for once, the mystery is too consistent to ignore. It points to a possibility that we may be missing a critical piece of the universe's early history. Or worse, that the universe we're observing might not behave like the one we thought we lived in. So now, scientists are no longer simply adjusting their models. They're asking questions that until recently would have been laughed out of academic journals. What if these objects aren't galaxies at all? What if we're not looking at the early universe, but something else entirely? Could these structures be remnants of a prior universe? Could we be observing data from a dimension beyond our own? A fragment from a parallel reality, or even an intrusion, something that doesn't belong here? Are we seeing through a rupture in space-time itself? To understand how serious this is, we have to explore the concept of the Hubble sphere, the region of the universe from which light has had time to reach us since the Big Bang. As the universe expands, objects farther away from us appear to move away faster. At a certain distance, known as the Hubble limit, galaxies recede faster than the speed of light, not because they're moving through space, but because space itself is expanding. According to general relativity, this should make it impossible to observe galaxies beyond that limit. And yet, Webb is receiving signals from beyond that barrier, light that by all accounts should never have reached us. The only explanation is that space itself may not behave the way we thought it did. The boundary of the observable universe may not be fixed, and light may be arriving from regions of space-time we were never supposed to see. These findings suggest that our universe has holes, gaps where the known laws of physics no longer apply. The light we're seeing may not be from our universe at all. It may be entering through a fracture in the cosmic fabric, leaking from somewhere else. This isn't just a fringe idea anymore. Some of the most respected physicists in the world are now openly questioning the Big Bang model itself. If galaxies formed faster than our laws allow, if light is arriving from beyond cosmic boundaries, and if structures appear that defy time and scale, then maybe the universe didn't begin the way we thought. Maybe it didn't have a beginning at all. Maybe what we're seeing isn't a timeline of cosmic evolution, but a collision point, a place where two universes overlap, or where something much older is bleeding into our own. And then there's the sound. So one of the most overlooked discoveries from Webb wasn't visual, it was auditory, or rather, vibrational. While measuring the background noise of the universe, the telescope's instruments detected a faint, rhythmic frequency, a pulse, a signal repeating at perfectly spaced intervals. It doesn't match any known cosmic phenomenon. It's not a pulsar, it's not a black hole spin, it's not cosmic microwave background interference. Some astrophysicists have begun referring to it as the heartbeat beyond time, a name that captures both the mystery and the mathematical precision of the signal. More cautious scientists suggest it could be a signature of exotic matter, a theoretical substance that exists only beyond the boundaries of our universe. But here's the chilling part. This frequency is not random. It follows a mathematical pattern, almost as if it were encoded intentionally. Adding to the mystery, Webb has revealed something else: massive gravitational fields in areas where no visible matter exists. These so-called phantom mass fields bend light, distort space, and affect the motion of neighboring galaxies, but they cannot be seen. This isn't just dark matter, it behaves differently. It influences structures that shouldn't be connected. Some researchers now believe these could be gravitational shadows, the fingerprints of structures from another universe pressing down on ours. A theory once dismissed as science fiction is gaining traction again, that of a mirrored universe, a place where time flows backward and the laws of physics run in reverse. Webb has detected anomalies in the rotational patterns of distant galaxies, subtle asymmetries that defy our understanding of inertia and momentum. It's as if two cosmic systems are overlapping, pulling in opposite directions. If this is true, we may not be living in an isolated universe at all. We may be part of a multiverse. Worse, we may be entangled with another universe that reflects ours but behaves entirely differently. In perhaps the strangest twist yet, Webb recorded a light signal from the very edge of the observable universe. It was expected to fade and vanish, as all such signals eventually do. But then it came back. Not from the same place, and not from the same time, but with the same spectral fingerprint. The light had echoed. That's not supposed to happen. There are only two explanations. Either light traveled around a curved, finite universe, implying space itself is closed like a loop, or it struck something at the edge, something reflective, something that should not be there. The James Webb Space Telescope was built to reveal how the universe began, but it may have done something far more profound and far more unsettling. It may have revealed that our universe is not the only one, that there are other structures, other forces, and other realities beyond our own. The impossible galaxies, the phantom masses, the mirrored spirals, the cosmic pulse, and the echo. They are not isolated anomalies, they are pieces of a larger, more terrifying puzzle. One that suggests we are not alone in the cosmos, not just in terms of life, but in terms of space and structure itself. So now the question is no longer, where are we in the universe? Are we even in the right one? The discoveries made by the James Webb Space Telescope have pushed the boundaries of human understanding in ways few anticipated. What began as a mission to observe the early light of the universe has evolved into a profound confrontation with the unknown. Webb was built to validate our models of cosmic history, to confirm how galaxies formed, how time unfolded, and how space expanded. Instead, it has revealed anomalies so large, so consistent and so scientifically disruptive that they cannot be brushed aside as observational error or outliers. These findings are not just strange, they are systematic violations of what we believed were the fundamental rules of the cosmos. For scientists, this is not just unexpected, it is deeply unsettling. The early galaxies Webb has revealed are not merely early, they are impossibly evolved for their age. They possess mass, structure, and complexity that should not have been possible so soon after the Big Bang. In some cases, these galaxies appear to have converted all of their gas into stars, bypassing the natural processes of gradual formation entirely. According to every astrophysical model we have, this simply should not occur. Either we are looking at galaxies from a universe that doesn't follow our rules, or our rules need to be rewritten from the ground up. This is not a minor adjustment to existing theory. This is the start of a complete reassessment of how the universe works, and perhaps what it even is. And then there is the light. The James Webb Space Telescope is detecting signals from beyond the Hubble limit, beyond the edge of what we believed was the observable universe. If light is reaching us from regions of space where it should never escape, then the structure of space-time itself may be more complex than previously understood. We might be witnessing energy leaking from one universe into another. The boundary between our cosmos and whatever lies beyond it may not be a wall, it may be a membrane, porous in ways we do not yet understand. This light, paired with gravitational distortions that have no visible source, suggests the influence of mass that does not belong to our known universe. These phantom gravitational forces are not random. They have patterns. They act on nearby galaxies. They behave as if something, somewhere, is pressing into our universe from outside. The presence of a rhythmic, repeating frequency in Webb's deep space measurements only deepens the mystery. This signal, dubbed the heartbeat beyond time, defies classification. It is not a pulsar, nor a remnant of the cosmic microwave background. It is something else entirely, a patterned pulse that follows mathematical laws. This discovery raises questions that blur the line between physics and philosophy. Could such a signal arise naturally? Or is it the footprint of something intelligent, or at least intentional, embedded in the structure of space itself? We do not know, but its very existence invites us to question whether our universe is merely a random occurrence or part of a much more ordered system. Perhaps most unnerving of all is the idea that we are not just observing other realities, but interacting with them. Webb's data increasingly suggests that we may be entangled gravitationally, energetically, or dimensionally with other systems of space and time. Theories once relegated to the fringe, such as mirror universes or multiverse collisions, are now being revisited in serious scientific discourse. When galaxies rotate in asymmetrical patterns or display reversed behaviors, and when gravitational effects appear without cause, we are left with only one conclusion. We are seeing the influence of something we cannot see, something that exists alongside us or within reach of us, but not within the bounds of our current understanding. In the end, the James Webb Space Telescope has not just expanded our view of the cosmos, it has exposed the limitations of what we thought we knew. It has humbled us. It has reminded us that the universe is not required to conform to our expectations. And it has opened a door through which we may soon step into a new era of discovery. But that step requires courage. It requires the scientific community to admit that many of its most trusted models may no longer apply. And it requires all of us, scientists, thinkers, and ordinary observers, to reimagine our place in something far larger, stranger, and older than we ever imagined. What we are witnessing is not just a series of surprising findings. It is the quiet dismantling of certainty. It is the realization that our universe might not be alone, that it might not be primary, and that our understanding of existence may be based on only a sliver of a much broader reality. As the Webb telescope continues its mission, one thing is clear. The cosmos has secrets still to reveal, and whether we are ready or not, it has already begun to show them to us.